Alright everyone, this is going to be a video of an annotated diagram for a convergent plate boundary between two oceanic crusts. Now, for oceanic crust, you have to keep in mind your drawing of the crust has to be relatively thin. You cannot just draw a thick crust because it would be assumed to be continental crust. So, we are also already very familiar with what features are going to come out. There will be subduction, there will be a volcano, so it need to be featured within your diagram itself. So we begin with drawing the oceanic crust, relatively thin, followed by the other oceanic crust. Notice as I'm drawing this, that it's not just a simple matter of overlapping, there is an actual depression over here. Reason being, you need to identify that as a trench. Yeah, and second thing, we'll be labeling that these are oceanic crusts. Oceanic crust. Yeah, not oceanic crusts. Also, next feature to draw is sea level. Why it will be important, you will see in a bit once we draw the actual volcano itself, but this is the sea, so drawing the squiggly line itself is not enough. You still need to label that this is the sea. So we begin with the processes that result in this case, it will be the convection current in the mantle. So we start with step number 1. Good for you to be able to label the process because it paints a story. So you need to know the step by step. Convection, current, pulls two oceanic plates together. Okay, so this is step 1. And then as you can tell, for convergence, which this word together will help to highlight, it will also result in a compression force. And in this case, there will be one that sinks. So it's good for us to be able to explain why. Compression forces causes the denser oceanic crust to subduct. Please remember to include the word denser because otherwise there's no real reason for one to go underneath the other. Okay. Next part is the fact that this will melt to form magma. The subducted crust will melt under high temperature in the mantle. If you want to include high temperature and pressure, please do, resulting in magma. Still magma, because still underground. Okay, this will eventually raise up to form a volcano. Now if you notice, my volcano is tall. Definitely this is a stratovolcano. Yeah, but still. So this one, I will need to label, this is an oceanic trench. At point of subduction. Okay, now we could proceed with the step 4. Magma rises and solidifies to form a volcano. But usually when it comes to a convergent plate boundary between two oceanic crusts, we see a volcanic island. So this volcano, if you just stop here, the explanation seems to just show a volcano that could be existing underwater. So why do I purposely draw it above the sea level? You need to add on as it builds above sea level, it forms volcanic island. Good for you to know that this one usually doesn't exist on its own. So when you see a chain of volcanic island, also known as an island arc, that is what's happened between two oceanic crusts converging. I've had a question before, do I need to draw a smoke to show that this is a volcano? I would say that that is up to the artist's choice. Okay. Now once again, these are just the features with every single annotated explanation on it. If in the event the question is asking you not to draw an annotated diagram, but rather a labeled diagram, this would be what you draw. Now after drawing this, all the explanations step by step as numbered above, you can write it as a paragraph below.